All right, so this one is another one of those solve the triangle. So whenever it says solve a triangle, that means that you need to find all three sides and all three angles. And we're going to use SOHCAHTOA. Remember that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. The capital letters are the angles, and the lowercase letters are the corresponding side lengths. Here's a capital A, this is lowercase a. Here's a capital B, across from it, lowercase b. Here is C. C will always be 90 degrees, at least in a trigonometry class. And this is the hypotenuse, or the angle C. Remember also there's this relationship of a squared plus b squared equals c squared. They gave us A. A is 29 degrees. A and B will always be complementary in a 90-degree triangle and a right triangle. We should note that all of these are right triangles. So then that means I would say 90 minus 29. Now for, I don't know how to word this. Mr. Adams can do this in his head, right? But I'm going to use a calculator because there's something about slowing down and punching some numbers in a calculator that means I'm probably less likely to make a mistake. What happens when we do math, I don't know why, and I'm guilty of it too, we want to hurry up and get the answer. And when we hurry up and get the answer, we don't want to be bothered with writing things down or plugging things in a calculator, but that's where we make our mistakes. So I have learned through the years just to hit the buttons and write things down. So that's 61 degrees. Now the side length they gave us was A, which is 12.6. All right, cool. So now what they gave us was this angle A. And I'm going to use that angle because that's the given angle. I suppose you could use C, but they didn't give us, I mean, it's 90 degrees. That's not really helpful when it comes to these trig problems. And they gave us A. Now, what is A relative to capital A? Well, that's the opposite, right? So think of this as like the opposite. And B would be what we call the adjacent. And C would be the hypotenuse always. So B then is the adjacent, so I need cosine. Cosine of what? Cosine of 29 degrees. And while it looks a little weird to you guys, it's actually a number, right? Oh, wait. I don't know what the hypotenuse is. Cosine won't work. You know how I know that? Because when I went to plug in the hypotenuse, I realized, oh wait, I don't know what it is. The only thing I know is the opposite. So in order to solve this, I need something that has the opposite and also the adjacent. How about tangent? So because I need tangent, I'm going to change this to tangent of 30 or 29. So I'll say tangent of 29 degrees is equal to the opposite, which is 12.6, over the adjacent, which is actually lowercase b. Multiply both sides by lowercase b. These will cancel, and I get b times tangent of 29 degrees is equal to 12.6. So then to get b by itself, I'm going to divide by tangent of 29 degrees. So it seems a little foreign, but tangent of 29 degrees is actually a number. I got to plug it in the calculator to figure out what that number is, which we will do in about 2 seconds. But basically, I have effectively solved for B. So let's figure out what that is. So I turn on my handy-dandy calculator, and I'm going to say tangent. Oh, wait. Am I in degree mode? Yeah, because we were working on these problems yesterday. See how that says degree up there? If I wasn't, I'd hit mode, and I'd go down here, highlight degree, and hit enter. But anyways, I am in degree mode. And so I need to do 12.6 divided by tangent of 29 degrees. Now that gives me 23, let's do 22.7. And you say, Mr. Adams, why did you decide to round it to 22.7? Well, they gave us 12.6. 3 significant figures. 1 decimal place. I hear a lot of arguments about that. Like it's funny. I got into a big discussion with the professor at Northwestern one time. They were talking about significant figures, and one of my professors at Andrews University said, "You want to go with precision." So we could only be, and it's 1 less than the most precise measurement, which I found fascinating. But basically, he would say, he would argue that we're not really sure of this 0.6. So you wouldn't round to the 0.6, you would round to 1 less, which would be a whole number in this case. But sig figs is a different thing. The other professor was like, no, he had a very complicated rounding rule and all this stuff. So just write down 22.7 is where I'm going with this. Now from here, there's 2 ways to do this. I could actually find the hypotenuse using a trig function, or I could just do the Pythagorean theorem. So let's just do the Pythagorean theorem. We haven't done that in a while. Remember that a squared plus b squared is equal to c squared. So that means we're going to have 12.6 plus 22.7 is equal to c squared. This you could do in one swoop. So now remember, I want to get c by itself, so I'd have to take the square root of this whole thing, and I'd have to take the square root of this thing. So then c technically equals the square root of 12.6 squared plus 22.7 squared. Let's do it. So you could do that in one little calculation on your calculator. Put the square root thing down, start parentheses, 12.6, close parentheses, square that, plus, start parentheses, 22.7. Man, I'd say 26, wouldn't you? Yeah. So if I rounded it, it would be 26, roughly. And I probably, if I'm being a good math teacher, because we're doing some rounding here, instead of putting the equal sign, we should probably put the approximation symbol, which is a tilde, a double stack tilde. Okay. And those seem reasonable, right? What are some ways that I could double check to make sure those are reasonable? Well, one is the hypotenuse is always the longest side. It's not necessarily drawn to scale, but if you look at the triangle, it kind of looks right. Okay. The other thing we could do is we could actually, and it would only take a second, we kind of know what the adjacent over the hypotenuse would be, and we could see what that angle would be. In other words, I could do something like arc cosine of 22.7 divided by 26. Now, if I did my math right, it'll be close, but we did some rounding, so it won't be exact, but the angle should be close to 29 degrees, right? 29.1. Now, that 0.18 comes from the fact that we rounded some things. So, yeah, I'm happy with these answers. Okay? Does that make sense to you guys? Lastly, probably we should label the triangle. I forgot to do that. So don't forget. Let's label all these values in here. So angle B is 61 degrees. B is 22.7. We should do the approximation symbol for those. And C is about 26. My little tilde does not look like a tilde. There we go, that's better. And that's it. Yes?
So when you're just labeling the outside, will the side length be always be in between like in C then? Like on that side?
You mean when we write it down? Like the way that I label it, or you're talking about where it's...
Like right there on the triangle.
Yeah, so C, okay, that's a good question. So C will always be the 90-degree angle. Now sometimes you'll have A here, and sometimes you'll have B here. So let me just show you real quick. So maybe you have a triangle like this. Well, this will always be C. Well, maybe you have A here and you have B here. Okay? Well, C, lowercase c, is always across from the 90-degree angle. Now, lowercase a will always be across from the capital A. So if my angle A is here, right, this is angle A, then you go across, that's lowercase a. If angle B is here, across from the capital B is lowercase b. But maybe you have a triangle that's written this way. Well, let's do it a different color so we don't get confused. Maybe you have a triangle written this way, where this is our 90-degree angle. This is going to be C always. And you have a B here and you have an A here. Lowercase a is always across from the capital A. Lowercase b is always across from the capital B. And then C is always the hypotenuse across from the 90-degree angle. I don't know if that answers your question or not. Okay. Yeah. That's the way it works. And it's funny because, I think the first year I taught geometry, I didn't even tell my kids that. I just assumed they knew that. Because every problem you do in the book is kind of rigged up that way. Because that's the convention. That's how you would label your triangles and stuff. Okay, any other questions about this problem? Now, truth be told, when it comes to the Pythagorean theorem, if you accidentally do A and B wrong, the math still works out. C has to be the hypotenuse. But it's good to know this stuff. Okay?